Welcome back, Math 30-1. In today's lesson, we are going to be looking at modeling sinusoidal functions. So basically, we're doing last lesson, except in reverse. Here, we're given the graph, and we want to make the sinusoidal function, or we're going to be making the equation for the graph. Now, let's take a look at class example number 1. We have a nail is caught in the thread, rotating in a tire at point N. Okay? And here is the following sketch for it. Now, the tire has a diameter of 50 centimeters and rotates at 10 revolutions per minute. After 4.5 seconds, the tire touches the ground. Use the following information to give a scale of our x-axis. So I know after 4.5 it touches the ground. So that's one thing we know. And we also know that we have 10 revolutions per minute. So we have 60 divided by 10 is going to give me a total of 6 seconds per one revolution. So one revolution from here all the way to here is going to be a total of 6 seconds. Okay? So then I know we're counting by this. There's break it up into fours. This is going to be 1/4. If we look at our unit circle here, this part here is this. Then we go here, which will be that part. Then we go here, which is going to be this part. And then the final quarter is there. So we're going to have 1.5, 3, and 6. We're counting by 1.5s every time. This is going to be 7.5. Here it's going to be 9. And then we're going to have 10.5 there. Okay? Now, what else do we know about this is we have a vertical displacement of 25 because my diameter is 50 and we're going 25 above and 25 below, and we just touch. So my vertical displacement is 25, and my amplitude is going to be 25. Okay? Now, it wants us to determine the equation for this, the sinusoidal equation. Well, we know A is equal to 25. I know my vertical displacement is equal to 25. And we want to know now what is my period? Well, my period is equal to 6. Well, I want to figure out what my B is, which is equal to 2 pi over B. So I'm just going to switch these around here. So I get B is equal to 2 pi over 6, which is equal to pi over 3. Okay? So we have now, I believe, almost everything we need. Just check, is there a horizontal phase shift for sine? Nope, because right there we're starting where sine should be. Let's put in everything to my equation. So I have h of t is equal to, my height is equal to a, 25, multiplied by sine. And I'm going to have pi over 3 x. And I want pi over 3x, and we have plus 25. All right. Now for part C, it says, how far to the nearest tenth of a centimeter is the nail above ground after 6.5 seconds? So I'm going to use my calculator for this here. So I put in my y equals, and we have to plug in my equation I made. So we have 25, oops, going to go here, 25 sine, and then we have pi over 3x. So I'm going to go pi x divided by 3, second pi, and we have x, and we're going to divide that by 3, and we plus 25. So for my window here, I'm going to end up putting, for my x min, I want, my x min is going to be 0. My x max is going to be, I'm going to go to 10.5 right here, so my x max is going to be 10.5. So I'm going to put 10.5. Now my x scale, I'm going to count by 1.5s, so that's every quarter. Now my y minimum, I'm going to put -2, because so we could see everything. And my max, I'm going to put 55. Whoops. My y min is -2, and my max is, or -5 I have, we're going to put 55. And now I'm going to have a scale of 5, and we're going to graph. So here's my graph. And we want to know when the nail after 6.5 seconds. So I'm going to go trace 6.5, and above ground it is 37.5. So I get 37.5 meters. Or sorry, centimeters. Okay? Now let's take a look at question number 2. So question 2 says, the first Ferris wheel ever built was created by a bridge builder named George W. Ferris in 1893. The diameter of the wheel was approximately 76 meters, and the maximum height of the Ferris wheel was approximately 80 meters. Okay? The wheel had 36 wooden carts on the wheel, and each cart could hold approximately 60 people. Now, the Ferris wheel was introduced to the world in the 1893 World Fair in Chicago. So the illustration below is an actual diagram or picture of this Ferris wheel. So if the wheel rotated every 9 minutes to the exact, use the table to sketch the sinusoidal graph. So every 9 minutes we're going to use this table to help sketch this. Well, we're going to say the minimum, we're at 0, we're at 4 meters. Okay? Another way of looking at that is we have 80 and 76. 80 subtract 76 will give us my minimum of 4. Then at 2.25 we'll go to 42. So 2.25 we're going to be around 42. And then at 4.5 we are at our max of 80. And then at 6.75 we're going to be back at 42, and then here we're back at 4. So let's draw this out. We're going to get a nice little graph that looks something like this. Okay? And now it wants us to determine the equation of the graph. Well, this wants us to do a cosine graph for the sinusoidal function. I'm going to just zoom in here a little bit so we can see my work. We're going to start off with my A value. My A is equal to my max minus min divided by 2. So it's going to be 80 minus 4 divided by 2, which is going to give me 38. Now, I know my period is equal to 9. So my B value is going to be equal to 2 pi divided by 9. And we're just going to leave it like that because that's an exact form. Next, I want to know my horizontal display or my horizontal phase shift. Okay? Well, I look at this here. We should be starting right there, which is 4.5. As we look above, it's 4.5, and this is where we should be starting. So my horizontal phase shift is 4.5 units or 4.5 rads to the right. So I'm going to put that down here. It's going to be 4.5 rads or radians right. Okay? Now I want to know my vertical displacement. Okay? So my vertical displacement is going to be actually my max plus my minimum. And then we're going to divide it by 2, which is going to be equal to 41 is my vertical displacement. Okay? So if I was to put this into my calculator, 42. 84 divided by 2 is 42. So if I'm going to put this into my calc or into the equation, everything back in, I'm going to have h of t, my height as a function of t is equal to 38 cosine, and my b value is going to be 2 pi over 9, and then we're going to have here at t, my time, to the right, so it's minus 4.5. And I want to go, and we have d, which is plus 42. So my next question says, how high to the nearest meter is the cart 5 minutes after the wheel starts rotating? So I want to know 5 minutes, so I'm going to plug this into my graph here. So I'm going to go here, y is equal, clear that, and I have 38. And I want cos, put in my brackets, 2 pi divided by 9, 2 second pi divided by 9. Put another bracket in there. I'm going to actually close brackets this. Okay, and we want t, so that's going to be x minus 4.5. Make sure I have enough closing brackets. 1, 2, 1, 1, 2, And that should be enough. I might need a third. Nope, that's good. And we have here plus 4.2, plus 4.2. And I want to change my window. So my X max here is going to be 9. So I want 9, or I'm going to leave it at 10 for my X max. My X scale, I'm going to count by ones. My Y min, I'm going to put 0. My Y max is going to be 85, or we can even put 90. Okay, and my Y scale we're going to count by tens. I'm going to graph this here. Oh, I have 4.2. That's why it looks wrong. I'm going to clear this up, delete. Now let's graph it again. Looked kind of funny before. There we go. That looks a lot better. So there's my graph. It looks very similar to what we drew there. Okay. So how high is the cart after 5 minutes? So t is in minutes, so I'm going to go trace, and I want 5, enter. My cart is going to be 77.7 meters, and it wants it, starts rotating. It's going to be to the nearest meters, so that's going to be 78 meters is going to be the height of my cart. Now it says, how many seconds after the wheel starts rotating does the cart finish, or does the cart first reach 10 meters from the ground? So I want to know how many seconds does it reach 10 meters from the ground. So here I'm going to have to go y is equal to 10. Graph, and I'm going to find the intersection, because we want to know the height of 10. So we want the y value of 10. So I'm going to go second calculate, and I want to find my intersect. And we're going to go all the way down. I'm going to change my window so I can see that. I'm going to go to my y min is going to be minus 20. Because it was getting hard to see where it's going to intersect. Okay, there we go. So now I'm going to second calculate, intersect, and go and find it here. So go all the way over. Now I can actually see my intersection when I'm doing my tracing or my calculations. And we want right here, enter, enter, enter. I end up getting 0.8159. So x is equal to 0.8159 minutes. So I'm going to have to times that by 60. So I'm going to go second quit. And I have 0.8159 times 60 will give me, I look at this here, I'm going to end up getting 49 seconds. Okay.